Welcome to Nano Analytik GmbH, Germany. Nano Analytik GmbH developed several high-speed scanning probe instruments based on piezoresistive, or so-called self-sensing, and self-actuating probes. These probes are also known as active cantilevers. They can operate without conventional optical beam deflection or piezoelectric stacks for excitation. A common approach for probe measurement is based on optical readout. However, the shortcomings of optical detection associated with diffraction and reduced sensitivity necessitate the development of novel measurement methods to quantify probe-sample interactions. Due to restrictions on the optical readout, the dimensional downscaling of conventional scanning probes reaches its limits. Hence, the direct integration of readout and actuation onto the cantilever is essential for further miniaturization. Here you can see what the active cantilever looks like. It features three main elements. The piezoresistive Wheatstone bridge is located on the base of the cantilever and detects its deflection with 0.1 nanometer sensitivity. Our unique feature is a thermal-mechanical actuator which allows static and dynamic bending of the cantilever. It means the cantilever is excited at its resonant frequency and can be bent statically to follow the surface topology. Finally, an integrated silicon or diamond tip contributes to precise surface measurements. Active cantilevers allow for the measurement of surface topology and related surface characteristics, whereby the integrated actuation enables the control of the tip position. Here, the system is even capable of measuring the thermal mechanical noise of the cantilever. Image of the AFMinSEM taken with the infrared camera of the SEM/FIB tool, where the AFM is tilted at 60 degrees relative to the SEM column. To create the tool, a sample scanner that provided metrological capabilities was used. It was initially calibrated and tested by the manufacturer. The following are the performance criteria. This video shows the last phase of the approach procedure and the beginning of the imaging. We can zoom further in and see how the tip follows the surface topology. On the left side is a video taken with the SEM showing a fast auto approach, followed by the scanning motions of that stage. And the video on the right side shows how quickly the resulting 3D image in the AFM software builds up, practically in real time. The field emission scanning probe lithography module enables the use of an AFM cantilever tip as a field emission FE source. In this mode, it emits low energy electrons, less than 100 eV. This is in addition to its normal function as a scanning probe in the non-contact mode. Already in 2010, we showed that this configuration operates not only in vacuum, but also in ambient conditions. These pictures show the result obtained after wet development. To increase the lithographic throughput of the scanning probe lithography, we employ the so-called mix and match technique. In the left picture, you can see lines exposed with the E-beam, 10K EV, of the electron microscope. It means that large patterns have to be exposed with a lithography technique such as optical or E-beam lithography, capable of exposing large features in a very short time, albeit with low resolution. The left picture shows the accuracy of alignment between both exposure techniques. The precision can be measured immediately using the AFM mode. Besides high resolution capability, overlay alignment accuracy, and reliability, the combination of FE, SPL with other lithographic methods, i.e. mix and match, opens new horizons for cost-effective sub-10 nanometer nano manufacturing. These pictures show the beauty and ease of using this technique. The nano-analytic GmbH, AFM, and SEM system has high user friendliness, high reliability, and high flexibility in simultaneously using all SEM operation modes without any restrictions. The nano-analytic GmbH, AFM, and SEM control system is used also for a wide range of applications, ranging from contact and non-contact atomic force microscopy, AFM, and diverse setups in air, vacuum, or liquid, to high-resolution scanning probe lithography, EBID, and mass detection measurements. The nano-analytic GmbH, AFM, and SEM systems produce results with outstanding scientific quality.